What if I told you a 73-year-old man helped cure his own cancer with something you've probably never even heard of? Well, in this episode, we're going to figure out how to live a little bit longer, better, and still enjoy life along the way. And this is probably one of my favorite episodes of all time, maybe top 5. I sit down with Samuel Shepard, a biochemical engineer who was diagnosed with a rare terminal blood cancer, and instead of accepting it, he went deep into research and discovered a compound called astaxanthin. You've probably heard about it, seen it on social media, but his story is different. His product is different. So we began talking about aging, inflammation, and all these free radicals that actually drive disease and why most people over 40 start breaking down. We talked about how this one compound might target things at the mitochondrial level and is different than anything else you're taking as far as antioxidants. So if you're serious about longevity, fat loss, staying healthy, not getting inflammatory diseases, not getting arthritis, a whole slew of things that Samuel talks about, you're going to want to hear this one. So I keep talking about my SKOOL community that I'm on, and I've grown into about 100 members, and I'm really trying to help out the over 40 crowd, putting a platform out there that's better than Facebook groups. I really love this SKOOL setup. Having any type of discussion, if you can look at the tabs here, from general discussion to focusing on diet, movement, inflammation. This is just where I'm spending my time. Once again, check out the show notes for the link, or if you just Google over 40 fitness hacks SKOOL, SKOOL, I will be the first thing that pops up on Google with the SKOOL emblem right there. And you can sign up that way. Check us out. Hope to see you there. Sam, I just want to thank you for coming on my show. You know, I talked before we hit the record button that just the best part of being a podcast host is getting to talk to experts such as yourself and people in the longevity, health and wellness game that's just different from the education that I got as a personal trainer. And as we're aging, aesthetics don't really matter that much anymore. We want to live just a little bit longer. I don't know if it's 10, 15, 20 years, and everyone's different, right? But as my audience always knows, when I get a new guest on, we kind of want to get to know you. How did you get into, the field you're doing? And then we'll get into this new supplement that I know nothing about. So I'll let you take it away.
All righty. As you can see, I'm 73 years old. And early on in my life, my background is in chemistry, physics, undergraduate. I have a bachelor's in chemical engineering and a master's in biochemical engineering. So I started out in the petrochemical industry, produced polymers, plastics, polyethylene, polystyrene, and then moved very quickly into consulting, where I did consulting for several international companies. I spent time in China building the wastewater treatment infrastructure, or helping them build it for the 2008 Olympics. I was involved in the Lunar Outpost Commission from 1991 to 1994, and got involved in the development of electromagnetic pulse weapons, auditory weapons, and bioweapons. And in 2003, I was having some health issues with regard to, I couldn't get my blood pressure down. I don't smoke, and there was no real reason for it. Come to find out that I had a terminal bone cancer called polycythemia vera. There was no chemo. So when I got called in, my blood was very thick. It was ketchup. I was pushing blood pressures of 280 over 160, and I knew I was going to stroke. I knew it would knock me down, and they tried to manage it. Well, only way to keep me alive was I was phlebotomized every month. Where I would go in and they would take my blood out and the solution to pollution is dilution. Yeah. That's sort of the same game they played with me. And I did that for every month for 4 years. At the end of that 4-year period, I only had a 3% chance of making it to 10 years. That was the bad news. But at the end of about 4 years, I was having much more difficult and trying to get my blood pressure down. And I went in one time and never knew how high your blood pressure could get or how high the blood pressure cuffs would go. Well, I went in one day and it actually pegged on one blood pressure cuff. They went to 3 others. They all pegged. 300 millimeters is the highest a blood pressure cuff can go. And I pegged out the top of that. And I thought my eyes were going to blow out of my sockets. That's the feeling I had. So I knew that it was coming down to, I probably was going to stroke. And that was a little unacceptable. So I had access to ProQuest, which was a DARPA DOD database. I had all the tools in the toolbox. If somebody could figure this out, I was probably in a position with all the gifts that God gave me, all the tools in my toolbox, I could figure this out. At least I thought I could. So I'm sitting there one very dark morning, about 4 o'clock in the morning, and I'm going, there's got to be some other purpose to life. than just to end like this. And it just sort of came to me that there's got to be something on this planet that doesn't get cancer. And that was the seed. That was the point at which, well, let me go research this and just see what leaves or trees or animals that don't get cancer. Well, I found 5 animals that apparently have no recorded cases, very low recorded cases of cancer. And that was salmon, pink flamingos, sharks, elephants, and naked mole rats. So I went to Scripps Oceanographic in San Diego.
Wow.
I was working on a DARPA project with General Atomics in San Diego at the time, and asked them if they could get tissue samples of those 5 animals, and they could. And I asked them put what's called a screening algorithm in the data. So I wanted to know every molecule that should not be in any of those animals, so we could screen out proteins, lipids, carbohydrates, vitamins, enzymes, hemoglobin. We could screen out all of that stuff. I'm looking for the molecules that shouldn't be in any of those species, but it was found in all 5 of those species. And it took them about 4 months, and came back and they said they found one. And I said, I was shocked, to be honest with you. And I said, what is it? And they said, it's astaxanthin. The astaxanthin comes from an algae called Hematococcus pluviale. So I went to the University of Texas, got the algae culture from them. And then these Intex blow up hot tubs. I call them hillbilly hot tubs. So I went to Walmart, got one of those, put a plastic cover over it, bungee corded it, so totally sealed. And it would send bubbles. I could put CO2 in. It was temperature controlled. It was perfect for growing algae. So I seeded it, and I began growing this algae. And the algae is green when it's growing. So I knew from a group in San Diego how to stress the algae and to make it produce large amounts of this astaxanthin. So when the algae itself feels stressed, like its pond is drying up, the water is evaporating, like at the Salton Sea area. When the water begins to evaporate, the salt concentration increases. That was the trigger that the algae's pond was drying up, and it wanted to protect itself against the sun was going to burn it as the water evaporated. So it would produce this astaxanthin, push it to the cell membrane, and block the UV light of the sun, lay in the soil, waiting for the next 100-year rain, and then it would come back to life again. So we knew the entire cycle of this. So I began growing it, added salt to my reactor to simulate an increase in the salinity. And within 48 hours, the algae went from green to deep red.
Wow.
And I was able to dissolve air float the algae to the surface. I skimmed it off. I put it in a dehydrator. I knew it was 3.8% astaxanthin in the algae. So I could calculate based on a certain dose I wanted to take, how much of this algae do I have to eat? So start out at 4 milligrams per day. I didn't want to kill my liver. It's a red algae, and everything that I was ever taught, red things are usually toxic, whether it's red tide or red mushrooms or whatever. You just don't eat things that are red. So I didn't know whether it was going to kill me with kidney failure, liver failure at that time. So started out a fairly low dose, about 4 milligrams per day. And after about 3 months, I noticed my phlebotomies was about once every 2 months now. So the slope of the climb out from day 1 of a month to day 30 of a month, I had a certain climb out for 4 years. So I had a nice control slope as to how my hemoglobin climbed out over that period of time. And then at 4 milligrams, the slope. Now it took me 60 days to get to the same endpoint on my hemoglobin. Now, statistically, it wasn't all that significant. I could account for it in error or just in uncertainty. But it wasn't killing me. I had my blood work done. Everything was looking really good. So then I got brave and I said, okay, let's triple the dose. So I went from 4 to 12 milligrams a day. At 12 milligrams a day of eating this algae, my phlebotomies got pushed out to once every 4 months. So that was significant. So now I had a control slope like that. I had 4 milligrams like this. I had 12 milligrams like this. So I had 3 slopes of the curve. Now I could calculate how much do I have to take so that I'm never phlebotomized for the next 50 years of my life. And it came out to be 96 milligrams a day. On paper, if I took 96 milligrams a day, based on the rate of decline of those slopes, I should not ever be phlebotomized again. So I started taking the equivalent of 100 milligrams a day, and my phlebotomies ended.
Wow.
And that was shocking to me. I'm the only known cure of polycythemia vera on the planet. We now have several other people who had polycythemia, and they're now cured because of this ValAsta. They don't have this problem anymore. So it took me a while, years, to figure out why did it work. Now, I taught biochemistry in Houston, Texas at Lone Star college, and I've taught here at University of South Carolina also. I've got a real good understanding of the biochemistry of how the human body works and the chemistry involved on why we can even have this conversation. So I had the background to figure this out. And well, in the course of figuring it out, when I looked at what's called the JAK2 STAT3 mutation in the gene, it's activated by certain free radicals. So I found the 4 free radicals that cause 92% of all human disease: the superoxide, singlet oxygen, the peroxyl, and the hydroxyl free radical. There's also a nitril, an RNS, reactive nitrogen species, but that's not entering into this. That's more of a whole different pathway. So I was able to figure out exactly from my polymer background, because we would initiate polymerization reactions using these free radicals. So I understood the free radical chemistry very, very well. Well, the same thing was happening in the human body. These free radicals, when they got to a certain level, began to mutate the DNA. The DNA is a polymer, plastic, and it's an information-loaded plastic, but it is basically units tacked on. And what I found was that the hydroxyl reaction happened at the G in the DNA. That's the lowest oxidation potential amino acid. So I knew where the reaction was happening. So then I began to think that all cancers are common in having that DNA mutation. So I began to give this to family and friends who had stage 4 cancers. These people had 2 to 4 months to live, 3 to 6, less than a year, and their cancers went away. It was the most remarkable thing. It was shocking to me. Some of these people were home with hospice, and hospice left. And you'll see some of the testimonials on the website. The website is ValAsta.net, but we now have thousands of cancer cases that their cancer was eradicated: melanoma, colon cancer, glioblastoma, which is really a tough one, lung cancer, inflammatory breast cancer. They all are responding to this antioxidant. Now,
That's what I was going to say, to kind of water it down from my audience. In what I kind of looked at, like ChatGPT already, basically it's in the antioxidant category. We're going after free radicals, and it seems to go intracellular to the mitochondria. And, I kind of compared it to, I know glutathione's a good fighter of inflammation, and it's an antioxidant. Fasting in general is not an antioxidant, but it's a, inflammation clearer, but they all do different things. And astaxanthin seems to go right into that mitochondria, which, is the powerhouse of your whole body. So now that's kind of making sense of how potent this stuff is.
That's exactly right. Now, when we're young, there are 4 antioxidant, intracellular antioxidants that sit right at the mitochondria. So when the mitochondria processes sugar into energy, or pyruvate, it produces the OH on the glucose, becomes a free radical. Now, we have glutathione, we have catalase, and we have superoxide dismutase. Those are the 3 antioxidants that we have protecting us from too many of these free radicals. Now, when we're young, we're producing large amounts of that. We can do a lot of stupid things when we're young and get away with it. We stay up late, we eat a lot of pizza, we can eat sugar, we can drink beer. There's a whole bunch of things that we do in that younger period. But at average age of 42 in women and 50 in men, nature stops producing glutathione. It's nature's way of taking us out. And at that point, we start experiencing these, they call them age onset symptoms or age onset diseases. We get a little arthritis in our joints. We get a little bit of type 2 diabetes. We get irritable bowel. We start the beginnings of cancer or heart disease, Alzheimer's. These are all free radical generated. So the best analogy is, think of a giant oak tree. You got a big root structure in the ground. That root structure are all of the things that cause the trunk of the tree to form. So in that root structure, you have sugar, you have alcohol, you have UV radiation, you have environmental pollution, you have all these things that's adding to your inflammatory disease tree. Well, the trunk of the tree are these 4 free radicals. Those 4 free radicals then go up the trunk and they present, depending on the person, different diseases. Doctors stand on the ground and treat the tips of the branches. Only treat the symptoms of that disease tree. Well, what ValAsta does is it cuts the tree off at the trunk. It neutralizes all 4 of those free radicals, so none of the branches can form. And that's how it works.
So before you kind of came up with with your version of all this, was there already supplements for astaxanthin out?
There was a couple things we found on the way, and that's a great question. Astaxanthin has been around for probably 15 years, I would say. But what I found was when I was eating the algae, I cured my disease. But as a chemical engineer, you start to think that if I had a more pure form of the astaxanthin, it should be more effective. So what we did is in the astaxanthin world, we could do what's called a supercritical CO2 extraction. So we could just extract the astaxanthin from the algae. So when I switched to that, thinking that would be better, my cancer came back. And where I was taking 100 milligrams a day, when my hemoglobin began to climb out again, and I had to go through a couple more phlebotomies, I sort of panicked a little bit. So I just kept increasing the dose of the extracted astaxanthin until I got well over 800 milligrams a day before it turned and started back down again. So then I knew that the astaxanthin that was in the algae itself was different than the astaxanthin I got after I extracted. There was something different. So when we did a spectral analysis, what we found was the algae exists in the algae cell in two forms, either a glucosidic or a liposomal. So the glucosidic means that you have, think of this earpiece, that's the glucose molecule there. This is the astaxanthin molecule, and it's chemically bound to it. Now, in the algae cell, that's the way it exists. When we ran it through the supercritical CO2 extraction, the high pressure cracks the glucose off, so all you end up with is this straight chain of astaxanthin. That became very important because it became an absorption issue in the small bowel. Glucosidics, pharmaceuticals, and in the world that I was in bioweapons development, glucosidic organic compounds are more absorbable into the human body much quicker in the small bowel because of that sugar molecule being attached to it. And all of a sudden, when in chemistry, one of the things that we can do, because temperature will inactivate astaxanthin, high temperature. So you need high temperature to chemically react glucose back onto the astaxanthin. But if I raise the temperature, I destroy the efficacy of the astaxanthin. So in electrochemistry, at certain frequencies of energy, I could vibrate the OH molecule on both the astaxanthin and the sugar. And that was enough bond energy to cause them to stick. And the byproduct was water. So without raising the temperature of the astaxanthin. So I developed that magnetron that we now use to put the glucose and the astaxanthin as two separate molecules inside, and we hit it with that frequency, and those two chemically bind. That's called a glucosidic astaxanthin. And it's the only patented astaxanthin that was ever allowed by the patent office. It is patented. The only one I know of a natural substance that was ever allowed to be patented. So that was the key. And that's what ValAsta is.
So other supplements back in the day just ripped it apart and you were just getting the astaxanthin. And then going back to pulling it straight from the algae, showing your AirPod, what was that connected to the astaxanthin that was, naturally found in the algae? What was that molecule?
Yeah. The algae itself makes the entire glucosidic astaxanthin. It makes this glucose, it attaches that astaxanthin.
But you pulled it apart and put your own glucose onto it. Why? Because it's better.
Yeah, because the only way that we could purchase it instead of eating the biomass. Gotcha. So I went ahead and purchased the pure astaxanthin that you can get at Walmart or wherever. And then I reattached.
No one wants to eat the biomass of the actual algae and turn pink.
No, especially at some of these doses, you're eating a lot of biomass. And that's what convinced me that I didn't want to eat that biomass anymore. Let's just extract the astaxanthin. But ValAsta allows for the increase in absorbability of the astaxanthin into the bloodstream. One interesting part is that you cannot change the alkalinity of your bloodstream. It's always 7.35. If it's 7.3, you're going to be sick. If it's 7.4, you're going to be sick. It's very tightly controlled. So you can't alkalize your bloodstream when people talk about taking alkalizing agents. But in cancer cells will use 32 times more sugar than a normal cell will. So its mitochondria is producing these hydroxyl free radicals at 16 times the rate of a normal cell. Well, these hydroxyl free radicals have a pH, acidic pH, of between 5.2 and 6.7 is neutral. That's water. So all around the cancer cell is these acidic free radicals, and they destroy normal cells adjacent to the cancer cell, and they die, and they make room for the cancer cell to grow. That's how tumors grow. That's where the space comes from. Well, what a free radical is it has an unpaired electron in its outermost orbital. Extremely reactive. No matter what it bumps into, it's going to steal an electron to try to reach a new stable configuration. Well, when the astaxanthin and the glucosidic astaxanthin that's in the bloodstream gets close to the cancer cell sees that sugar and says, man, I need that for fuel. It's called a Trojan horse, and it sucks that sugar in. Well, the sugar's chemically bonded to the astaxanthin, and so it sucks it inside the cell. Inside the cell, enzymes crack the sugar off, and the cancer cell uses that for fuel, for feed. Now the astaxanthin is intracellular. It's inside the cell. Now the astaxanthin will donate an electron to the hydroxyl free radical, which has a 0 charge. It has the same number of protons as it has electrons, but it's missing one in its outermost orbital. As soon as that thing donates an electron, that OH 0 charge becomes an OH minus 1. It becomes a hydroxide ion. That carries a pH of 12. The phospholipid membrane of the cancer cell membrane ruptures, and the cancer dies in 4 seconds. It is the most remarkable thing to watch, but it's a very simple, it's called saponification. It's a very simple chemical reaction. It's how we made soap. Back in the 1800s, we used fatty acids, and we reacted it with caustic, like soda ash or sodium hydroxide, and that would make soap. That would make lye, and that's how we made soap. Well, the phospholipid membrane around the cancer cell is all fatty acids, and it does not like the hydroxyl ion and that high alkalinity in pH. That's where Warburg didn't quite figure it out when he got the Nobel Peace Prize. How did it? Because cancer can't live in an alkaline environment, and really no cell can. But the advantage is a cancer cell dies, it doesn't reproduce. Normal cells will reproduce exactly the same way without the mutation.
So, you know, in my mind, I'm thinking the kind of the stuff I know, I'm not saying that this cures cancer. Obviously, you got to throw that out there. But from just all the biohacking stuff I've learned, you know, fasting is huge, letting your body kind of clear itself out, being in a more alkaline state, which you said you can't really change your blood too much anyways. So that one kind of doesn't do well. Cancer loves sugar, you know, whether that's been proven or not, that's kind of on the biohacker thing. So for me, if someone's got cancer, you can only benefit from fasting as much as you can tolerate, doing a low sugar diet, and then now introducing these Trojan horses, because now you've got a system that has no sugar. The second it sees your Trojan horse, it's going to grab onto that even faster. It just seems like it all just synergistically works better.
Survival is the key. Even on a macro level, I realized that I was going to die. That's how I came up with this. It's a tremendous motivator. You know, without getting philosophical or religious or anything like that, but it changes who you are when you're faced with that. And I still think that translates down to the micro level with the cancer cell. It'll do anything it can to survive. And cancer truly is living on an edge, a very difficult surviving edge. We now know all cancer cells, 100% of cancer cells are anaerobic, which means they do not need oxygen to survive. It's like a fermenting yeast. Brewing beer, I guess, is the best analogy. So it is right on the edge. And all of these antioxidants, turmeric, curcumin. Turmeric, for example, has what's called an ORAC score, an oxygen radical absorption coefficient. It's the ability of it to absorb free radicals. Well, it has an ORAC score of about 122,000. That's really high. Dark chocolate is about 20,000. So you can still have your dark chocolate bar, and you're still fighting inflammation when you do that. But the ORAC score for turmeric's 122,000. ValAsta is 2.2 million. It's 20 times more potent than turmeric. So that means you can reduce the dose and get the same effect. The results are pretty amazing. People with arthritis, chronic arthritis, they find complete relief in 7 days. This is not something that you have to wait on for very long. We've had complete cancer turnaround as measured by CA markers or cancer markers, CEA markers in cancer. They peak, and then you see it drop off. Once it drops back down again, all the cancer cells are pretty much dead. The title of the patent, which sent ripples through the industry, the title is a method for the process of using astaxanthin for the treatment of inflammatory disease, particularly for the treatment of cancer. And as you know, FDA says you must have disclaimers. This product cannot be used to treat, cure, or diagnose any disease. Well, the patent office requires that I publish my patent number. So they're in direct conflict with each other. Let the people choose which way they want to go with.
You know, with my little ChatGPT session prior to getting on, you know, I threw curcumin in there as well. And it mentioned that, you know, astaxanthin having a higher ORAC score and all that. And so that's only part of the equation from what I've learned, that the ORAC score is not for everything. Glutathione doesn't have an ORAC score because it's naturally produced in your body. And I've seen wonders, you know, adding certain supplements that have worked and, you know, the effect I get on it. And what I'm finding out, listing all these things onto ChatGPT, besides just being an antioxidant, which there's tons of antioxidants, you have to look deeper and be like, what are you actually trying to go for? And that's what even ChatGPT mentioned. Astaxanthin is going intracellular into that mitochondria. And hey, there might be another reason to take a different antioxidant, and there might be a different reason to take glutathione. And, you know, for the purpose, like I put weight loss. For me, glutathione detoxes the liver like nothing else. And thus your metabolic powerhouse and your organ in your body is pumping at full charge. I will see the results on my trackers and I will burn more fat. That's not what astaxanthin is trying to do. It is doing exactly what we've been talking about. So you have to know kind of what you're looking to do when you start stacking your supplements like this.
Correct. Vitamin C, for example, the ValAsta is about 6,000 times more potent than vitamin C. But vitamin C has a parabolic dose response curve. Small dose seems to be highly effective. You can reach a point with megadoses where it becomes a pro-oxidant. Your liver has to process that vitamin C, and in so doing creates an inflammatory response. Linus Pauling saw the same thing. With astaxanthin, it does not convert into a pro-oxidant. It's one of the only antioxidants that exogenously, from outside the body, is not a pro-oxidant or processed in the liver.
But there are reasons to take vitamin C for other benefits in the body than just being an antioxidant.
Correct. Ascorbic acid, for example, is one of the critical components in a certain pathway to producing enzymes or other vitamins that our body produces. So there's other reasons to take vitamin C. The other things that we found in this adventure was that people, for example, have prostate cancer. What's the first thing they want to do is they want to chemically castrate or knock the testosterone levels down. Well, what we found is testosterone does not cause cancer, and it doesn't feed the cancer. Same with estrogen and inflammatory breast cancers. Testosterone itself is not a carcinogen. Otherwise, we'd have all these young boys full of cancer. Estrogen the same way, we'd have all these young girls with inflammatory breast cancer. So they are not carcinogens. But in the testosterone world, there is one called dihydroxytestosterone. That is a known carcinogen. Yep. So what happens is testosterone reacts with a hydroxyl free radical and produces dihydroxytestosterone. Now, what medical industry does is says, okay, we got to knock your testosterone level down. Okay, you're never going to get to zero in men. We're always going to be producing some testosterone. The reality is ValAsta knocks the hydroxyl down, which is what's actually the limiting reactant, not the testosterone. So when we take the hydroxyl free radical out to less, and we measure it with a blood test called HSCRP, everybody should run that. Just be aware, make sure your doctor includes it in your blood work. HSCRP.
Yeah, that's always on there.
That's a measure of your inflammatory disease state. So if we can knock that down under 3 milligrams per liter, you've just knocked the probability to less than 3% of you getting an inflammatory disease. So that's really important. But we can knock the hydroxyl free radical almost to zero, or at least down. We have to have some inflammation for cells to communicate. But it's not testosterone. Same with estrogen. It's hydroxy. Estradiol is what the known carcinogen is. It's not the estrogen. It's the reactant or the product of the reactant of estrogen plus the hydroxyl free radical yields hydroxyestradiol. Hydroxyestradiol is the carcinogen.
So when they say that when they're screening people for taking testosterone therapy, they're screening for cancer like crazy because they say that testosterone is like sprinkling fertilizer on cancerous cells. That's not entirely true. It's not the testosterone. It's the byproduct of testosterone, which is the DHT, that is what you have to worry about. Okay.
Correct. Especially in bodybuilders, anytime that you exercise your muscles to the point your mitochondria is really active, trying to repair, trying to do things, you generate a lot of these free radicals. If you take testosterone or steroids When you're in that oxidative disease state, very high concentration of hydroxyl free radical, you just increase dramatically the probability that you're going to end up with a DNA damage or a cancer type of inflammatory disease. That's what's doing it. And steroids will react with the hydroxyl. Stress is extremely important. Keep your stress level, because we produce hydroxyl free radicals whenever we produce epinephrine, norepinephrine, cortisol. Those are adrenal type hormones that when they are processed through the liver, they generate a huge concentration of these hydroxyl free radicals. And it goes back almost to the biblical side. Why worry? It's not going to add another day. It's actually going to end your life prematurely. Don't worry, because your worry creates these fight or flight hormones that, when they're metabolized, puts you in an extreme inflammatory disease state.
Yeah. Wow. I mean, that's
fascinating stuff.
The whole story and everything you went through was just incredible. And I can't believe that it was never on my radar until you reached out. So, and funny enough, like I told you, even ChatGPT, whatever you think about that, just going through my personal stuff, it basically said, no, besides being in your workout routine is great, this would probably be stacked higher than even your glutathione supplement. If you only care about losing body fat, then it said, okay, go ahead and put your glutathione on top of that. But for longevity, it was like number one. It's like, how come you never mentioned this to me before then? That's what
there's a real good reason, but we're in 27 countries. We're in all 50 states. We've done no marketing. This is it. This is about this. It was all done by testimonials. People getting cured of cancer tell 100 people. And it went completely around the world. We have offices in Singapore, Australia, in Europe, in Africa. It went completely around the world just by word of mouth. I took classes at the Wharton School of Business, where back in that time, it was how many billboards can you put up, next to a highway? How do you add this? Social media stuff has just changed the marketing approach, unbelievable levels. Things travel at the speed of light
especially
now.
If it works, then you don't have to do anything. Let it go viral.
So when you go to ValAsta.net is the website, you'll see all the testimonials there. There's over 1,000 peer-reviewed articles on it from the National Institute of Health. In April of 2019, I testified in Washington to about 200 people. Several hospitals were there, and I revealed what actually causes inflammatory disease. And it sent ripples, because if you can prevent these diseases from ever happening, it changes the entire medical industry. And they were concerned. And so they issued a lot of money to the National Institute of Health to see if, in fact, my research was correct, if I could reproduce it. And I thought, they're going to go there and try to prove it didn't exist. But if you go to a search engine and you just look NIH and astaxanthin and cancer, or and heart disease, or and Alzheimer's, they've got all the research completed since 2019. And all these papers, these research papers are there. But doctors don't read research papers. I am a researcher. I've done that for 40 years of my life. These are things that I read, but doctors do not read them. Doctors rely on the research being done by the pharmaceutical company, so they become the gatekeeper. We don't want to cure disease because we have
drugs to treat it, our symptoms.
Right. Yeah, so we don't want to do that. And now with this social media and the availability of what the NIH has now published, the layperson can now read these and understand them and see the effects of astaxanthin in clinical work and in animal work. It's all there.
No, that's great. And, I'm only dabbling, looking into some of that research just on ChatGPT. Now that I know how to prompt it with everything you just said, I can just go nuts on it. So,
it's shocking. And there's no contraindications. So if you're taking other medications, it does not interfere with it, because it's a completely different pH modified way of treating cancer. It's not a direct chemical like chemo.
Well, man.
Yeah, you start to reach the point where age becomes more, can I just survive through tomorrow? Not the good looks that I used to have. I'm not much interested in that anymore. I'm just trying to keep my hair. But that's one of the things also with women, because dihydroxyestradiol causes hair loss.
And that's what I'm taking. I've been taking finasteride, Propecia, since I was 19 years old, and it did its job. But the thing was to take out that DHT or keep it at low levels, because DHT is what eventually attacks, if you're genetically prone to it, your hair. So you're saying this could also help with that by...
Yeah, it doesn't work so well on men because our testosterone levels are so high. But in women, it works well. And I call it the TE ratio. It's a testosterone to estrogen ratio. So as women get older, their TE ratio increases. Their estrogen drops off, but their testosterone levels remain the same. So that ratio begins to increase. And that's, if they let it get too high with the dihydroxyestradiol, their hair will start to, they'll get bald spots. Their hair will start to fall off. So we can stop that. In men, the TE ratio goes the other direction. Our testosterone drops off, but our estrogen levels remain the same. So our ratio begins to go down. We lose our aggressiveness, become almost more feminine, softer. We're not into fistfights as much as when we were younger. We're not as aggressive. We take a more calm approach. But as the testosterone drops, if we maintain a low inflammatory disease state as measured by that HSCRP, then we're going to be fine. You don't have that predisposition to get cancer.
Very cool. This is some powerful stuff that I just can't believe is, like I said, not been on my radar. But well, Sam, besides your website, which you've thrown out there, and I always put everything we talk about for links in our show notes, what other things you want to direct my audience to? Do you have any social media, YouTube? You were talking about the research papers. Is that all on your website?
It's all on the website. And the one thing to keep in mind, also, MIT figured out what causes Alzheimer's disease. So there's a whole technology on our website called VLED, V-L-E-D. And that is an external electromagnetic pulse. It's light at a certain frequency. And we pulse that through the eye, and it activates the microglia in the brain. And the microglia eat the amyloid beta plaque and stops the progression of Alzheimer's. That technology is also found at ValAsta.net. We have other technologies that aren't on there that I'm working on right now in the supercapacitor world to replace lithium iron phosphate batteries. That's a whole other discussion. So as long as my brain still works, I'm still going to be in awe.
I know. And we need it. We need it, Sam, because not all of us are gifted with that.
I'm just old, Brad. I'm just old. You got to pick up something along the way.
Well, awesome. Well, Sam, I'd just like to thank you for taking some time to be on my show and giving some education. And, you know, I love the fact that you can, someone at my level, personal training, and I'm just doing low-level biohacking and trying to live a little longer. You know, obviously you could have a totally different discussion with other doctors and scientists that just shoot over our head. So you're an excellent speaker, and just appreciate what you do.
Thank you. A lot of years teaching students that have no idea and how you have to present these concepts so they can visualize them. And that was the whole idea, was that if you could visualize how this was actually working at the microscopic level, and you had a picture's worth 1,000 words. You can see this. You can see how this is working. And it wasn't something that happened overnight. This was not an easy journey.
Well, we appreciate your time, and, you know, your job is to teach and keep researching, and my job is to push this information out. So
get it out there.
Get on it.
Let these people know.
Yeah, excellent.
Be very proud of what you're doing, Brad, and the number of people that you're going to impact.
And I love doing it. This is the whole reason I'll never stop podcasting either, is I had no idea that some of this stuff even existed. So excellent.
Anytime. You got any questions, don't hesitate.
Right. I appreciate it, Sam.